Professor Rad here, and today we're going to do a little bit of mathematical clairvoyance, looking into our mathematical futures. So in the future, you may need to be taking an algebra course. And algebra is essentially it's basically the same as arithmetic, just taken to the next level. So you might hear it phrased as like a generalization of arithmetic. So let's see why. Okay, and remember, a generalization takes something from a specific situation and brings it to a broader situation. So let's take a look first at an example we might see in our arithmetic class using the addition process. So here we've been asked to add 315 and 74. So we can split 315 up based off of its place values into 300 plus 10 plus 5, and 74 into 70 plus 4. And then we combine the like place values, right? So we bring down our 300, we had our 10 and our 70, which brought us 80, and the 5 and the 4, which brought us 9. This one doesn't have any carrying, so we can just rewrite that as our answer, 389. And another way we could see this is visually, so I drew it out in pictures here. But I'm going to focus on the numerical expression for the moment. Let's look now at an algebra example. Take a deep breath, it's okay. I'm not going to ask you to do this. We're just illustrating what this will look like. So we have 3x squared plus 1x plus 5, and we're going to add that to 7x plus 4. So I rewrote out the 3x squared plus 1x plus 5 and the 7x and the 4. And notice that some of these pieces that are being added together have a letter, and some of them have like a letter squared, like this one has an x squared. And this is the only one that has an x squared on it. So I'm just going to leave it alone. Then the 1x and the 7x, those were the two that had an x together. So I added 7 plus 1 and got 8. So there's my 8x. And then 5 plus 4, those are just normal numbers. So we can just add those and get 9. So in the end, I wound up with 3x squared plus 8x plus 9. So really what's going on here is these x's are stand-ins. You could think of them as like stand-ins for place value. So notice 315, 315, 310, 5, 3x squared, 1x, 5. So it's just an x squared instead of 100, and it's an x instead of a 0. Same concept, just a different name, just a different way of writing it. Same thing is happening with 74 and 7x plus 4. Okay. So 74 split into 70 and 4, 7x instead of 70, 4 as just 4. And then when we added them in our answer, we wound up with 3, 8, and 9. And in the answer here, we ended up with a 3, an 8, and a 9. So we can see there's one thing that's different in the algebra answer, in that there's still these plus signs in our answer. So our answer kind of looks more like just before our final answer, but that process of how we arrive there is going to be the same. And the reason we can't add these all together, we'll save for an algebra class. But hopefully you can kind of see the parallel that's going on here. Understanding this addition process for arithmetic is going to make this process of adding like terms or simplifying or adding algebraic expressions together when you get to an algebra course. So that's where I'm going to stop this one. Just a little peek into the future. In our next video, we're going to work through an alternate method for addition. So if you're like, not for nothing, Professor Ad, but this, this process seems really long-winded, is there a way that I can do it without writing quite so much? There is. And if you know a traditional addition algorithm from your past, you may be a little bit more comfortable with that one. So that's what we're going to look at in the next video. So yeah, I hope you enjoyed this peek to the future, and I'll see you next time. Bye for now, everybody.